Next video is applications of derivatives. First question says, let f be the function defined by f of x equals 4x cubed minus 5x plus 3. Which of the following is an equation of the line tangent to the graph of f at the point where x equals -1? So remember, in order to write the equation of a tangent line, we need two things. We need a slope and we need a point. Now I already have the x-coordinate of that point. The x-coordinate is -1. If I want to find the y-coordinate of that point, I need to plug it back into the original function. So if I plug in -1 here, let me just do some work over here. If I plug in -1, I get 4 times -1 cubed, which would be -1, minus 5 times -1 plus 3. So that's -4 plus 5 plus 3, which is 4. So the y-coordinate is 4. Now the slope, if we're looking for a tangent line, the slope of the tangent line is the derivative. So I'm looking for the derivative evaluated at -1. So that would be f prime of x would be 12x squared minus 5. And if I evaluate that at -1, I get f prime of -1 to be 12 times -1 squared minus 5. Well, -1 squared is +1, so this is just 12 minus 5, which is 7. So my slope is 7. Now, automatically I can start eliminating some of my answer choices based on that. I know it's not going to be D, because that one has a slope of -5, and I know it's not going to be E, because that one also has a slope of -5. So from here, I would plug it into point slope form, which would be y minus y1 equals m times x minus x1. So that would be y minus 4 equals 7 times x plus 1. Now, if this is a free response question, I would rather have you leave your answer like this, but since it's not a free response question and it's multiple choice, we have to figure out which of the answer choices is equivalent to this. So if I distribute 7, I get y minus 4 equals 7x plus 7. And if I add 4 over to the other side, I get y equals 7x plus 11, which is answer choice C, final answer. An equation of the line tangent to the graph of y equals x plus cosine of x at the point 0, 1 is. So again, as a reminder, in order to write the equation of a line, we need a slope and we need a point. And in this case, they're kind enough to give us both the slope. They're kind enough to give us the point, both coordinates of it, just not the slope yet. So it's our job to figure out the slope. And the slope of a tangent line is the derivative. So the derivative, y prime, would be the derivative of x is 1. The derivative of cosine of x is negative sine of x. And if I evaluate that at the x value we're looking at, which in this case the x value we're looking at would be 0, I get y prime of 0 to be 1 minus sine of 0. Well, sine of 0, if you think about the unit circle, sine of 0 radians, this is the point 1, 0. And sine is always the y-coordinate. So sine of 0 is 0. So this would be 1 minus 0, or 1. So my slope is 1. If I plug this into point slope form, I get y minus y1 equals m, which is 1, times x minus x1. Again, free response. Leave your answer like this. Please, please, please do not change it. On a multiple choice, however, we have to figure out which one of ours matches this. So I'm going to distribute the 1, and I get y minus 1 equals 1x, or just x, minus 0. And then add the 1 over to the other side, we get y equals x plus 1, which is answer choice B, as in boy. Next question we do get to use a calculator for, so go ahead and grab your calculators. It says, which of the following is an equation of the line tangent to the graph of f of x equals x to the 4th plus 2x squared at the point where f prime of x equals 1. So this is being asked in a little bit of a different way, so be careful with that. In this case, instead of giving us an x value to find the equation of the tangent line at, now they're giving us a slope. They're telling us that the slope is 1, and it's our job to go back and figure out what x value made that true, and then, of course, which corresponding y value is relating to that x value in this equation. So first things first is, in order to figure out where the derivative is equal to 1, I need to know the derivative. So the derivative of this function is f prime of x. So the derivative of this would be 4x cubed 4x cubed plus 4x. And I want to know what x value made this equal 1 because it's asking me at the point where f prime of x equals 1. Well, here's f prime of x. I want to know what made this equal 1. So you could solve that on your calculator, or you could solve it by hand if you wanted to, I suppose. I think I'm going to solve it on the calculator just so that we get a little bit of extra practice with it. So let me grab my calculator and set it up really quick. Alright, so we wanted to know where 4x cubed plus 4x, which is the derivative of our function, is equal to 1. And again, we got that from what I had written over here, but it erased it already. So I said there's multiple ways you could do it. You could have brought the 1 over to the same side and made it all one equation and found the zeros, but my favorite way to do these problems is to enter it as two different equations and then find the point of intersection. So I have my window set as negative 10 to 10 on the x-axis and the y-axis, and then I graphed it, and I got this. So you guys can see that my first function, which is that cubic function, is right here, and then the second function at 1 is right here. So remember, to find a point of intersection, I would go to second, calc, intersect, which is option 5. The first curve, it already highlighted it up here for me as the cubic. I'm going to push enter. It jumped down to the second one at 1. I'm going to push enter. And then because there's only one point of intersection, as long as you're anywhere near that, remotely near that, that's a perfect guess. So I'm just going to say yes, my guess is 0, enter. And then it found the point of intersection for me. So the point of intersection was at 0.2367. Now remember to be accurate to at least 3 decimal places. So for 0.2367, I want you guys to make sure to write that down, 0.2367. So we have so far a slope. We know that the slope is 1 because that's what it gave us right here, f of x equals 1, or sorry, f prime of x equals 1. We have the x coordinate of our point, which is 0.23, I'm just going to put 0.237, comma, I still need the y coordinate of that point. So in order to figure out the y coordinate that corresponds to this, I'm going to come back to this equation, x to the 4th plus 2x squared, and I'm going to plug 0.237 in there for the y coordinate. So let's do that now. Alright, so on my calculator I did that. I got 0.237 to the power of 4 plus 2 times 0.237 squared. And that's, again, what we had here. What we had here. We just plugged it into that original function. So I have my slope at 1. I have my x value and my y value. If I plug it into point slope form, I get y minus y1, which is that value we just found right here, 0.115 equals the slope, which is 1 times x minus x1. And the x1 value is what we were plugging in, 0.237. So if I simplify this, if I distribute the 1 and then add the 0.115 over, I get that y is equal to 1x, or just x, and then negative... I know you guys can't see my calculator doing this because it's frozen from what I'm writing on the screen, but essentially I'm just figuring out what negative 0.237 is plus 0.115. So negative 0.237 plus 0.115 is equal to negative 0.122. Negative 0.122. And that's answer choice D. X minus 0.122 would be the equation of the tangent line in this case. And again, that's what I did earlier in my calculator just to figure that out, negative 0.122. All right, let's come back over here, and we'll keep going. Oh, this is another calculator question if we need it. I'm looking at it, though, and it doesn't look like we need it. This is actually the same question from your quiz that some people decided to try to do for extra credit. And like I was saying in class, there was only one person that actually got this question correct, and we'll talk about why that is right now. It says, let f be a differentiable function with f of 2 equals 3 and f prime of 2 equals negative 5. And let g be the function defined by g of x equals x times f of x, which of the following is the equation of a tangent line to the graph of g at the point where x equals 2. So again, we're back to this whole idea of a tangent line. We need a slope, and we need a point. I know the x-coordinate of the point is 2. To figure out the y-coordinate, I would plug it in here for g. So g of 2 is equal to x times f of x. That would be 2 times f of 2. So that would be 2 times, if I look up here at the directions again, f of 2 is equal to 3, so that would be 2 times 3, which is 6. And that's the y-coordinate. So I know that my point is 2, 6. If I look here at my answer choices, the only 3 options it could be at this point now, I guess it could be 3x if that ends up being my slope, but I kind of doubt that's what's going to happen. So here we have a point at 2, 3, so I don't think it's that one. Here we have a point at 2, 6, 2, 6, 2, 6. So I'm guessing it's either C, D, or E. So I'm just going to cross these off to keep it in the back of my head. Now to find the slope, again, we need the derivative of g. So g prime of x. And again, this is where most people made their mistake on the quiz, is that they didn't take the derivative of this correctly. I'm going to read it very carefully. This says x times f of x. Again, x times f of x. This is a function of x times another function of x. So when we take its derivative, we need to use the product rule. Now, I'm not going to write out my u and my v. If you would like to, please be my guest. But I'm just going to say it out loud, and hopefully you guys will start to catch on to that the more I do it. So the product rule says to take the derivative of the first, so the derivative of x is 1, and multiply times the second, so multiply times f of x, plus the first, which is x, times the derivative of the second, and the derivative of f of x is f prime of x. And now if I evaluate this derivative at 2, g prime of 2, I get 1 times f of 2 plus 2 times f prime of 2. Well, f of 2 is 3. We already talked about that. So this would be 3 plus 2 times f prime of 2, which is negative 5. If I simplify that, I get 3 minus 10, which is negative 7. So my slope is negative 7. And so, therefore, my answer would be answer choice D, because it has the correct slope of negative 7, and it has the correct x and y value at 2, 6 from the point there. Next question says, if the line tangent to the graph of the function f at the point 1, 7 passes through the point negative 2, negative 2, then f prime of 1 is. So this is worded a little bit differently maybe than some of the other questions we've looked at. But essentially they're saying that the tangent line goes through these 2 points and they want to know what the derivative is. So let's do some remembering on concepts. We know that f prime of 1 is the derivative. The derivative is the slope of the tangent line, and the tangent line goes through these 2 points. So we essentially need to know the slope of the line that goes through these 2 points. Well, other than the concept part of it, that's something you could have done in pre-calculus. We know how to find the slope of a line that connects 2 points together. It's just y2 minus y1, so negative 2 minus 7, over x2 minus x1, negative 2 minus 1. That would be negative 9 over negative 3, which is positive 3. So yes, it is that easy in terms of doing the math, but it was the difficult part of this problem was making sure that you understood how to get here. So as a reminder, f prime of 1 is the derivative, which is the slope of the tangent line, and if the tangent line goes through these 2 points, that must have the same slope as the tangent line. The next question says the function f is defined by f of x equals x over x plus 2. What points on the graph of f have the property that the line tangent to f at xy has a slope of 1/2? Now, quite a few people attempted this as the problem that they wanted to do on the quiz, and some people were able to get it, some got half right, and some didn't quite make it. So I want to talk about it in detail. Essentially, they want to know what values of x, and then we'll come back to the values of y, but what values of x make this function have a slope of 1/2? So remember that the tangent line's slope is the derivative, so I want to know where the derivative is equal to 1/2. Now, if you look at this function, obviously it's a division problem. We're going to have to use the quotient rule. Again, I'm not going to write down my u and my v. If you need to write that down, please, I encourage you to do so, but I will say it out loud so that you guys can see what I'm writing when I'm writing it. So f prime of x. The quotient rule says to take the derivative of the top, so the derivative of the top, which is x, would be 1 times the bottom, so times x plus 2, minus the top, which is x, times the derivative of the bottom. So the derivative of x plus 2 is just 1. All over the bottom squared, so all over x plus 2 quantity squared. If we simplify that a little bit, I get x plus 2 minus x over x plus 2 quantity squared. Simplify one more time, and we get 2 over x plus 2 quantity squared. Now again, I need to know where this, which is the derivative, I need to know where the derivative is equal to 1/2. Some of you guys got to this point, and then at this point you just started plugging in numbers to see which would be true. And so you could do that, or you could actually solve it mathematically. So you have the benefit that this is a multiple choice question, so you could just kind of plug it in until you figured out which ones worked. But I'm going to solve it mathematically just so you guys can see that. So from here we have our proportion. 2 over x plus 2 squared is equal to 1 over 2. So you can solve our proportion by cross multiplication. So I'm going to multiply across 2 times 2 and 1 times x plus 2 squared. I'll write my work over here. So 2 times 2 I get 4, and then 1 times x plus 2 squared is just x plus 2 quantity squared. Now you can solve this by taking square roots. If I take the square root of both sides, I get that plus or minus 2 is equal to x plus 2. Remember that every time you have to physically draw in the square root, you need to include the plus or minus. So now I have two equations. I have that 2 equals x plus 2, and I have that negative 2 equals x plus 2. If I solve for x, I get x equals 0. If I solve for x over here, I get that x equals negative 4. So I know my two answers are at 0 and negative 4. That leaves me with either answer choice C or answer choice D. Now 0, 0 is obviously the common thread in both of those. So, oh, sorry, I lied. This isn't even a negative 4. This is a positive 4. So that's not my answer either. This one must be my answer. You can check it out, though, just to make sure. If I plug in 0 to the original function, I get 0 over 2, which is 0. That's where they got this y-coordinate from. If I plug in negative 4 to the function, I get negative 4 over negative 4 plus 2. That would be negative 4 over negative 2, which is a positive 2. And that's where they got that y value from. So those are the 2 points. All right, this one we need a calculator for as well. So do me a favor and pull your calculators back out. It says the graph of y equals e to the power of tangent of x. And I know we haven't looked at these derivatives yet algebraically, but we get to use a calculator for it. So we don't need to worry about how to find the derivative on our own. The calculator will do that for us. So it says the graph of y equals e to the power of tangent of x minus 2 crosses the x-axis at one point in the interval from 0 to 1. It says what is the slope of the graph at this point? So we're going to go ahead and graph it in our graphing calculators. So give me a second to enter it as y1. All right, so again, here I entered it as y1. I have e to the power of tangent of x minus 2. I'm going to go ahead and graph that. I have my same viewing window as before, negative 10 to 10 for all of these. And I'll graph it, and it looks like that. So kind of an interesting function. It's periodic because of the tangent. All right, and that's what it looks like. Now, I guess I could have paid a little bit more attention to this in the beginning. It says that it crosses the x-axis at one point in the interval from 0 to 1. So those are probably good x values to look at. So let me come back to my window, and I'm going to change my window from 0 to 1 for x values so that I'm only seeing the one time it crosses the interval there. So I'll come back to my graph one more time. And it's growing a little slower now. Perfect, there it is. And you can see the one point that it crosses the x-axis. So let's first figure out what point that is. I need to know where it crosses the x-axis. Now we have a couple options. You could use the 0 feature. So we'll do that together just to make sure that we're all clear on how to use the 0 feature. The other option is if you graphed another line in y equals, you could plot for y equals a second function at 0, and then you would just find the point of intersection for those two. But we'll practice with the 0 feature just to get you guys on board with both of them. If I want to find this 0, I go to second, calc, 0, which is option 2. It wants a left bound. So I know this is from 0 to 1. So if this is about halfway through the interval, a number that's for sure to the left of that is 0.1, enter. A right bound, I need a number that's for sure to the right, so I'm going to say 0.9. I know I'm probably going a little drastic, but that way it'll help me out later. 0.9, and then it wants a guess, and I think it looks like it's pretty much halfway, so I'm going to guess 0.5. Kind of close. It happened to cross at 0.606. So let's keep that here, and then we'll come back, read the question one more time to see what else it's asking us. The graph of this function crosses the x-axis at one point in the interval from 0 to 1. We just calculated that point. It's right here, 0.606. It says, what is the slope of the graph at this point? So I need to know the slope at, excuse me. All right. I need to know the slope at 0.606. Now remember, the slope of a function is the derivative. So I essentially want to know what the derivative is at 0.606. So I need to evaluate the derivative of this function at 0.606. Technically, you can do it from the graph, but I always prefer that you do it from the home screen. So I want you to keep that number. All right, keep that number in the back of your head, 0.606, and I'm going to go back to my home screen, and I'm going to find the derivative of this function. And let's review one more time how to find a numerical derivative on our calculators. So second quit will take me back to the home screen. Remember to find a derivative, we're going to go to Math, and then I don't want you to scroll down every time. I would rather have you memorize this, but just to show you what it is, we're going to n-deriv, numerical derivative. So option 8, and it should put this on your screen. So the important variable we're working with is an x, so I'm going to say that it's d dx, the derivative of, and then I'm going to insert the equation. Now again, you could retype this whole thing, e to the power of tangent of x minus 2, but I know that I already entered it for y1, so I'm just going to recall it from there. So to recall it, you go to alpha f4. Alpha f4 pulls up all of your y functions that you've inserted, and I inserted it for y1, so I'm going to put y1. And I want to evaluate this function's derivative at 0.606. And if I do that, it tells me that the derivative of this function at 0.606 is 2.959, or if I rounded it, 2.960, or 2.96. I guess I didn't get close enough. I think the closest one is probably answer choice D, 2.961. Let's see why it didn't give me 2.961. So if I come back to my graph one more time, and I'm going to really quickly just go back to that 0. It's probably because I didn't use enough values. So it was actually 0.60638. 0.60638. So let's come back here, and let's try that one more time. 0.60638. Let's see if that one gets me closer. 2.963 now. Did I type that incorrectly? I'm guessing I typed it incorrectly. All right, the answer choice is D. It's close enough. But it's probably because of the number of significant figures that I'm using, or the number of decimal places that I'm using. I'm sorry. So the slope of the tangent line at that point is answer choice D, 2.961. Right there. I'm guessing, by the way, that another reason it's probably not close enough is because some of these questions that I get are from older tests, from older versions of the AP test, and the calculators that they used back then weren't as accurate necessarily, and so that could have been another reason why it's a little bit different. But obviously this one's close enough that it's obviously D is the correct answer choice. The questions I put on your AP test, on your tests in this class, as well as the questions you'll see on the AP test, are up to date with the current calculators, so it will always be an exact three decimal answer. Just one more thing before we finish this question, I want you to notice A, 0.606, was the x value where it crossed the axis. So make sure that you're reading the question carefully every single time you do a question, because you might get something and you're like, oh, I got that answer, but then it's not actually what the question's asking you for. So make sure you're very thorough in answering the question completely and accurately. If we come back over here one more time, let's see what else we got. Oh, there you go. That was the end of that section.